Yeah. So now we will be starting alcohols, phenols, ethers. Okay, in the last class we have finished our discussion. We have finished our discussion till haloalkanes, haloarenes and questions related to those chapter. Okay, so from that sessions are highly helpful if you are preparing for NEET, JEE or EAPCET exams. Okay, so in the same way alcohols also we will be clearly discussing. Alcohols, phenols, ether complete chapter will be discussed here. Okay, and we will be discussing the numericals or questions related to this from different exams like JEE, NEET and EAPCET. Okay, now first of all tell me what do we mean by alcohols here. First of all, you know hydrocarbons, right? Hydrocarbons means what? You know, only carbons and hydrogens will be present. Okay, so the simplest hydrocarbon we know is CH4 you are saying. Now from this if I remove one hydrogen, what you can write it as CH3. This is what? Methyl group. So to this methyl group, to this methyl group I am adding OH group. What I am adding? OH. So we can say this as a hydroxy group. What is that? Hydroxyl. Okay, hydroxyl group. Okay, so these are nothing but just look at here. Alcohols are hydroxy derivatives of aliphatic hydrocarbons in which OH group is attached to an alkyl group. See, this is our alkyl group. To the alkyl group we have OH group. So we can say them as alcohols. Okay, now one more example you can see. Methyl is over. Next ethyl if you want to write. So ethane formula is C2H6. But if I write C2H5 you should call it as ethyl. What you should call? Ethyl. Okay, to this ethyl group I am adding OH. So ethyl alcohol. What is the name of this compound? Ethyl alcohol. Okay, so just try to write the names for few more compounds which I am going to write here. Just tell me. Like this. Okay, just write its name. So now what is the name of this compound? See here we have ethyl alcohol. Now see how many carbons are there? 1, 2, 3. So you can say propane. If it is only these 3 carbons means it's a propane. Now remove one hydrogen and replace with OH group. You can say this is propyl alcohol. What is the name of this compound? Propyl alcohol. Like this we are writing. Okay. So now these are the common names. What is the common name? You can say alkyl, like alkyl group first. After writing alkyl group you write alcohol. Okay, when it comes to IUPAC nomenclature you should write it as propanol. Like what is that? Propanol. Like this. OL should be the suffix for these compounds. Like OL will be the OH group is there means you should end the name as OL. Like ethanol. What is the name of this compound? Ethanol. Okay, and what about this? Tell me now. What is the name of this compound? See here we have methyl OH. Methyl alcohol is a common name. But IUPAC name nomenclature what I told you? It is ethanol. It is also methane, like methane you are writing, and ol. See 2 ovals are there here, E and O. So remove one oval here, E you remove. So it becomes methanol. methanol, like this, methanol. Okay, so this is how we will write IUPAC nomenclature. Okay, now what are the uses of these alcohols in our daily life? See, we know we are using sanitizers more effectively from this COVID times. Okay, see, we have alcohol based sanitizers. This alcohol based sanitizer contains high amount of alcohol. So if you take 100 ml of sanitizer bottle, so it will be contains something like around 74, 75 to 80% of alcohol will be there. Most of the alcohols, for example, I am taking here sanitizer, 100 ml sanitizer I am taking. So it will be contains how much ml of pure alcohol here? Most generally it will be isopropyl alcohol. What is the alcohol present? Isopropyl alcohol. See, 80% volume by volume alcohol will be used in hand sanitizer, it is mentioned. It means if you take 100 ml of bottle, it contains 80 ml of, our sanitizer contains 80 ml of alcohol and 20 ml of solvent like water or some solvent will be used here. Okay, so now it will eliminate the pathogenic agents on the surface of this hands or wherever we are applying that. Okay, so wherever we are applying this alcoholic sanitizer, so it will kills or it will eliminate the pathogenic agents. Okay, right. The next one, alcohol is used in alcoholic drinks also. Okay, yes. So you know there is like wine we will be calling right now. So how it will be prepared? See, alcohols are prepared by fermentation and distillation of fruits in brewery. So it means, for example, wine bottles if you take. So if you take wine bottle, so in that if you observe that there will be made from grapes, grape juice like that. Okay, so by fermentation of fruits we are going to get this alcoholic based breweries and all. Okay, and if you observe any alcoholic bottle, if you see the whiskey bottle, just search in the Google at least. So it will be mentioned as 35% 5 volume by volume alcohol percent they will be giving. So what does it mean? So if you take 100 ml of that bottle, I mean 100 ml of that bottle, 100 ml of that whatever the alcohol, whiskey or whatever if you are taking, so it will contains 35.5 ml of pure ethanol. Okay, so this is a quantity of ethanol that is mixed with the solvent like water and to make this 100 ml of water. Okay, so this is what you need to understand. Okay, so this is some of the important applications and we will be seeing them in our daily life applications. Okay, so look at here, and there are many other uses of alcohols also, but these are the important points to be remembered. Next one is how can we classify these alcohols and phenols? See, based on number of OH groups. For example, here I am writing CH3, CH2, OH. How many OH groups are there? 1. So this is monohydric compound. Okay, so the next here what I am writing, see, CH2, CH2, OH and OH. Like how many OH groups are there now? 2 are there. So this is dihydric alcohols. Okay, or I can say this is diol. Why I am saying diol? 2 OH groups are there now, so that's why diol. Okay, like that. It can be triol also. So where do we see triol? See, this is ethanol. Ethanol is our having daily life application, just now we discussed. So this is ethylene glycol. What is the name of this compound? Ethylene glycol. So ethane 1,2 diol also you can say. IUPAC name is ethane 1,2 diol, and it is also having good applications in synthetic chemistry, and especially we have discussed about, or you can remember that in car radiators we will be adding this ethanol, like this one, ethylene glycol. So why we add this ethylene glycol to the car radiators? See, it will decrease the freezing point of water, or it will increase the boiling point of water in the radiators. Okay, so that is what we are saying, coolant. Now coolant liquid will be added into the car radiators. So it is one of the important compound to be remembered. The next one is triol. So what is this triol? We have OH, CHOH, and the next CH2OH. So this is glycerol, you can say. So you can see this glycerol, it has very good applications in the cosmetic applications also, in the cosmetic chemistry also. Okay, that's it. The next one here, based on hybridization of carbon to OH group is attached. See, for example, CH2OH, CH3. CH2OH, CH, double bond CH2, okay, and here OH. So what makes the difference between these 1 and 2 compounds? Just tell me what makes the difference between these 1 and 2 compounds. Yeah, so you can just check here, if you observe these 2 compounds, the OH group is attached to an sp2 hybridized carbon. To which carbon? Whereas this OH group is attached to the sp3 hybridized carbon, right now? Yeah, so this carbon, like this type of alcohols are called as a vinyl alcohol. What I am saying? Vinyl alcohols. Okay, and these alcohols, see, it is attached to sp3 now. So if I remove this OH group, it will create a positive charge over here. So that positive charge is highly stable, and we can call this kind of species as allylic alcohols. What you can say? Allylic alcohols. The same concept we discussed even in haloalkanes chapter also. Okay, and not only these 2 things, we also have something like aromatic ring is there, like benzene, we are much familiar, right? So on this benzene, if OH group is present, you should call it as a phenol. What you should call? Phenol. Okay. So in phenol, OH group is attached to which type of hybridized carbon? This one. This is sp2 hybridized carbon. So in phenol, OH group is attached to sp2 hybridized carbon. Okay. In the same manner, what I am writing, just see. CH2OH. So here, these phenyl ring or benzene ring is attached to the CH2 group, which is an sp3 hybridized carbon, okay, on which OH group is present. So now what you can say, this as a benzylic alcohols. What you can say? These are benzylic alcohols. These are benzylic alcohols. Okay, remember these differences. Okay. Okay, that's it. So based on number of OH groups, we have dihydric, monohydric and trihydrics. Already we discussed clearly. Okay, this is one of the example, glycerol, which is a trihydric or triol. Okay, in the same way, if on the benzene ring only one OH group is there, what is the name of that compound? Phenol. If there is triol, so see 3 are there, so you should call it as pyrogallol. What is the name of that compound? Pyrogallol. Remember these names. Okay, based on hybridization we just discussed allylic and vinylic, that is also clear. Now just look at here, when the OH group is present on sp3 hybridized carbon, which carbon? So this carbon is sp3 hybridized. See how many groups are there around it? 4 groups are there, so 4 sigma bonds are there. So this is an sp3 carbon. So to this OH group attached sp3 carbon, how many carbons directly attached? Only one carbon directly attached now. So you should call it as a primary carbon. What you should call? Primary carbon. So just remember. It is no matter how many carbons here we have, but how many carbons are directly attached to the OH group containing carbon? See, only one, right? So it should be primary. Okay. Now next one is, I am changing a little bit here, OH group. Again this is also sp2 only, but if you observe, how many groups are surrounding this the central carbon which is attached to the OH group? 2. So it should be considered to be secondary. Okay. Now what I am doing, just see, I am writing COH and the same carbon C, yes, tertiary, it should be tertiary. Like that we have primary alcohol, secondary alcohol, tertiary alcohol. Now just identify here OH group, OH group, OH group. Identify primary, secondary, tertiary out of this all OH groups which I have placed on the compound. This top one, tell me whether it is primary, secondary, tertiary. See, it is attached to a carbon which is directly attached to only one carbon right now. Okay, there is no other carbons here, only hydrogens are present. So you should call it as primary. Okay, now what about this carbon? This side one carbon is there, this side another carbon is there. So one more hydrogen. It means two carbons are directly attached to the this central carbon. So it means you should call it as secondary. Now what about this one? One carbon this side, second carbon this side, and third carbon that side. So three carbons are attached now. So it is a tertiary. Okay. And now what about this one? This is only attached to the one carbon now. This one. So it means this alcohol should be considered as a primary. Okay. It is clear. Identifying primary, secondary, tertiary alcohols is one of the important thing to be noticed. Okay. So I hope it is clear. No confusions. Right. Yeah, the next one, allylic alcohols we discussed. So in this allylic, again we can say primary, secondary, tertiary. What is the thing here I told you? Tell me, out of these, compounds, which is allylic? Which is considered to be allylic? Tell me, out of these all compounds. First one you tell me. Is it allylic? No. Allylic means what I told you. OH group should be there. That should be attached to the carbon. Allylic alcohols means what? OH group should be attached to an sp3 hybridized carbon. That carbon should contain an sp2 system like this. Okay. So is it having any pi bond like this? No. This is not normal primary alcohol. Okay. Now what about this system? This is second compound, let us say. See, OH group is there. See, OH group is attached to a carbon which is, what is the hybridization of this carbon? One pi bond is there, means it is a sp2. Okay. So what I told you, if OH group is present on like methylene, sp3 hybridized carbon, then you can call it as allylic. But is this allylic? No. If this is not allylic, so then what it can be? See, it is directly attached to sp2 hybridized carbon now, so you should call it as vinylic. Okay, this is vinylic, not an allylic. Now tell me about this one. So allylic or what exactly? Allylic. So OH group is attached to a carbon which is sp3, and adjacent to that we have a double bond, that is sp2. So this is an allylic system. Allylic system. Is this clear? Right. This is perfectly correct. And this is also allylic system. This is, just check here. See, this is an sp3 hybridized carbon which is connected to sp2. So yes, this is also allylic. Okay. Now what makes the difference between this ABC? What makes the difference between this ABC? See, OH group is attached to a carbon. All of them are allylic only. But there is some difference. All of them are allylic only. But this carbon is attached only to one carbon. So you should say this as allylic primary alcohol. What is that? Allylic. What about this carbon? See, this is allylic, one side this carbon, again one more side carbon. So it is allylic secondary carbon. Okay. So allylic secondary alcohol. And what about this carbon? Tertiary. So this is allylic tertiary alcohol. Like this, the basic difference should be noticed every time. Okay. So why we need to understand in this much clearly? Because the reactivity they will ask now, which are the alcohol readily participate in SN1 reaction they will say. So we know in SN1 reaction, if carbocation is stability is more, the intermediate carbocation is formed as a tertiary carbocation, then that will be more stable carbocation right now. So based on that, now which allylic alcohol will be readily involves in SN1 reaction, they will ask you. So what is the perfect answer? See, tertiary allylic compound give more stable carbocation, no? Yes, then it will be more reactive. So out of these A, B, C compounds, so C will be more reactive than B, and least is A towards SN1 reaction. Okay, so it is very important to understand which is allylic alcohol and which is vinylic, which is benzylic, which is phenyl. Okay, and the next one is understanding primary, secondary, tertiary alcohols in that allylic systems, also important thing. Okay, so these are the factors to be remembered here. Okay, and after this vinyl, allyl, all these things are over. Okay, ethylene glycol, that is also done. So remember these common names, these are very important common names to be remembered. Okay, in the exam they will directly mention these common names. Okay, you need to identify them. So phenol means just on benzene ring we have OH groups. So orthocresol means what? So you know toluene, right? Or other ways you know phenol, right? So phenol with one methyl group. Yes, this together considered to be orthocresol. Okay, no. Paracresol or metacresol means what? OH group and methyl group should be at 1,3 position. So this is metacresol. Okay, paracresol means OH group and CH3 should be at 1,4 positions. Okay, that's it. Next, catechol means what? Catechol means 2 OH groups are there, like phenol is this one. So one more OH you put here. Okay, like this or this one. This is a perfect one. This is a perfect one. So this is catechol. Next one is a resorcinol. See, OH group, 2 OH groups, how do they relate? 1, 3 na. So 1, 3 position means OH group here and here. So this is a resorcinol. Okay, remember these names. Okay, and 1, 4 position is there means OH groups are at 1, 4 positions. OH and OH. So you should call it as a quinol. What is that? Quinol. So here I have mentioned. So take a screenshot, those who are in the live session, these are useful. The names are useful. Okay, yeah. So what is the common name I told you for them? Like common name means alkyl alcohol. Okay, so if it is 1, 2, 3, 4, what is a common name you can say? Like butyl alcohol. See, 1, 2, 3, 4 is there. Butyl alcohol. So now tell me, where do we have butyl alcohol? This is a straight sign now, so it should be called as N-butyl alcohol. So here you have N-butyl alcohol. So match this A4. This is A. Okay, next one. So what about this alcohol? See, 1, 2, 3, 4. So 4 is there. So it is at second position. So this carbon attached to 2 other carbons now. So it is primary, secondary or tertiary? Secondary. So you can say secondary butyl alcohol. So B, this one here. Okay, next one. So if you observe, there is a system like this. Okay, so if you have it like this, you should call it as isobutyl, like 1, 2, 3, 4 are there now. So isobutyl alcohol. So C1. Next, what about D? See, this carbon is attached to 3 carbons. So it means what you can say? Tertiary. So D2. That's it. So this is how you need to match their names. Okay. So these names, common names are important here, whatever we discussed. Okay. Right. So then how do you write IUPAC names for the same compounds? If I ask, how do you write IUPAC names for the same compounds? See, 1, 2, 3, 4 are there now. So you should call it as a butanol. What you can call? Butanol. Okay. What is the name of this compound? 1, 2, 3, 4. So at second position OH group is there now. So 2-butanol. 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 Okay. And what about this? See, identify the straight chain. 1, 2, 3. See, I am numbering from here because our principal functional group is at this carbon only. So it should be given least number. So 1, 2, 3. So at second position methyl group is there. So 2-methyl propanol, 2-methyl propanol. This is a IUPAC name of the compound. Now what about this name? See how many carbons are there? See 1, 2, 3. Okay, at second position we have one methyl group and one OH group. So what is the name of this compound? 2-methyl propane 2-ol. So what is the name? 2-methyl. It's a propane now. So propane 2-ol. That's it. This is the name of the compound. Propane 2-ol. Okay, so this is how you need to write. Okay, now preparation of alcohols. So how do we prepare this alcohol? Okay, it's again important. Okay, there are some methods to be remembered here, and first important reaction is hydroboration. What is the reaction name? Hydroboration. Hydroboration reaction, hydroboration oxidation. It means what? See, you will be considering alcohols, alkenes. What you are taking? Alkenes. Alkenes upon hydroboration reaction, hydroboration gives alcohols. What they will give? Alcohols. So give some examples for alkenes here. So you can take this alkene here. Okay, so what is the reagent used during the hydroboration? Yeah, you can use this B2H6. What is this? B2H6, half mole B2H6 you can write. Okay, and the next here along with this we will be using H2O2 in basic medium, NaOH. So this gives you alkene, alcohol like this. Okay, I will explain the mechanism. Just follow. First of all, you need to identify what is happening here. See, try to remember the reaction in this manner, otherwise the same compound I am writing here. This one 3 moles of alkene react with, see, B2H6. What is the monomeric form of B2H6? I can write BH3. Okay, this is a half of that. That is nothing but like half B2H6 is nothing but BH3 I can write. 1 BH3. Okay, so this happens in presence of hydrogen peroxide and NaOH, basic medium. So 3 moles of alkenes reacts with 1 mole of BH3, borane unit, and gives you 3 moles of alcohol. 3 moles of alcohol. Okay, I will tell you some points to be noted here, because with using these points you can attempt maximum questions from here itself. Okay, so it follows concerted single step reaction with 4-membered cyclic transition state. So during the mechanism, what it will be doing? It is a single step reaction, concerted single step reaction. Okay, so it has a 4-membered cyclic transition state. So during addition of, see what we are doing to the given alkene, we are adding 1 hydrogen and 1 OH group. So where we are adding hydrogens are means, see these are the double bond now. See, we remove this double bond means this carbon should be added with something and this carbon also should be added with something. Okay, so the terminal position I am adding OH group. It means this internal carbon should have H. Okay, so now from where this H comes? Yes, that H comes from borane. H comes from where? Borane. Whereas OH comes from this hydrogen peroxide. Okay, so OH comes from hydrogen peroxide, H comes from this BH3 unit. Okay, remember these points. Okay, and the next one here is what I am saying. This is a 4-member cyclic transition. Now, see. If I write like this, we know BH3, like this if I write, BH3 is like borane is a electron deficient site. What I am saying, it has only 6 electrons now, so it is an electrophile. Now it requires someone to give electrons. So the pi electrons are loosely bonded here in the alkene, so that will be shifts to the vacant orbital of this boron. Okay, so now when it is shifting, see the bond will be connected between this terminal carbon and with this boron. Okay, so that this carbon will be losing the pi electrons, means here it should be a positive charge right now. So to that this hydrogen is given. So if you observe, there is a 4-member transition state. Like this, we have a 4-member transition state like this. Okay, see, because simultaneously this carbon and boron is making a bond, at the same time this hydrogen coming from borane to our central carbon, like this happening now. So now this is a cyclic 4-member transition state we got. Okay, so this will be now treated with what? H2O2 NaOH. Okay, so now what happens here? The hydrogen will be added over there like this, and to this position we will get OH group. Okay, and I'm just giving a brief mechanism only, not completely. Okay, now what you are seeing, both H and B will be added from the same plane only now in order to make this ring. So both here hydrogen and the one which OH group you are adding here, both comes from the same plane only. So you can say it gives a 1 comma, like it gives a it follows a cis addition. The product it follows syn or cis, syn addition. It follows syn addition. What do we mean by syn addition? Both hydrogen and OH groups we are adding now, that should be from the same plane. Okay, it's very useful point. We have some stereochemical questions also from that. Okay, and one more thing here it should be remembered. It follows anti-Marconic. It gives the product formed will be the product formed is similar to anti-Markovnikov rule product, anti-Markovnikov's product. What do we mean by anti-Markovnikov's product? See, in the given product, if you observe, to the alkene we are adding two things, one is H and other one is OH. Okay, so if I take water molecules, you can write H plus and OH minus. Okay, so the negative part of addendum is going to the most number of hydrogen containing carbon of this alkene. See where it is going, the negative part will be added over here, OH, and here H. So the negative part of the water molecule is going to the terminal carbon. Okay, so that you will get this OH, and positive part is going inside. Okay, so this is what we can say anti-Markovnikov rule product. So what do we mean by anti-Markovnikov rule product? The negative part of the adding molecule goes to the more number of hydrogen containing carbon. Okay, so the carbon which is having more number of hydrogens, there I am adding this OH now. So that is why product is like this. Okay, so how this statement is made? Yes, it is purely based on the experimental, this mechanism observation only. Okay, so it will be, the product formed will be similar to anti-Markovnikov rule product. That's it. Okay, so during the reaction, cyclic transition state is seen now, observed now, 4-member cyclic transition state. During the reaction, no rearrangement. What I am saying, no rearrangement takes place. No rearrangement takes place during the mechanism. Takes place. There is no rearrangement. Only wherever we have double bond, there we need to do the chemical reaction. Okay, that's it. Okay, let me give you 1 or 2 examples and you will feel more clear on this discussion. See what I am writing here. BH3, H2O2, NaOH. Tell me what happens? What is the product formed? Tell me. So here the carbon is there, this carbon one alkyl group, the second alkyl group is there, and this side one hydrogen, this is methyl group. Okay, so out of these 2 carbons, which is having more hydrogen atoms, this carbon or this carbon? See, there is 0 hydrogens on this carbon. Here you have at least 1 hydrogen. So wherever we have more number of hydrogens, there we need to add negative part. Okay, it means OH group will goes to which carbon here? This side, this one or this one? The second carbon here, OH, and the first carbon should be added with hydrogen. Okay, they should be either from the above the plane or both should be from the below the plane. Like this you should do mention. Okay, that's it. This is how you need to write. Okay, and one last question I'm giving you. Just tell me. Yeah, where do you need to add H? Where do you need to add OH? Tell me, where do you need to add H and OH? It's similar to our discussion. Where H and where OH? Yeah. So write as it is like this. After that, see this carbon contains no hydrogens. Here it has 1 hydrogen. So what I told you, it follows anti-Marconi of addition. So more number of hydrogen containing carbon of these alkenes takes negative part. What is the negative part? OH group. So here it will take OH and here it should be taking hydrogen. That's it. So both should be from the same plane, either above the plane or from the below the plane. This is addition, you remember. Okay, that's it. That's it. This is about Marconi, like hydroboration reactions. Okay, and you are adding OH group now, so you can call it as oxidation. Okay, what is that? Oxidation. Addition of oxygen is taking, so oxidation you can say. Okay, next one is, this is about alkenes. Now we also have alkenes, right? Alkenes. See, if I take only simple alkene, that it won't react, it will not undergo oxidation at normal conditions. Okay, using any oxidizing agents. Okay, but if I have a tertiary hydrogen like this, if I treat this with KMnO4, with what? KMnO4. Now what happens is, this tertiary hydrogen is there now, tertiary carbon containing this hydrogen. Okay, so that will get oxidizes to alcohol like this. This is a product formed. Okay, hydroboration we clearly discussed. Now tell me, what is the product formed here? Where should I add OH and where should I add H out of these 2? The terminal group should be here H. That's it. How many moles the product is formed? See, 3 moles of substrate gives 3 moles of product upon treating with 1 mole of BH3 unit. Okay, so this is how you can remember cyclic transition state mechanism I told you. Okay, anyways here clear description is there for the mechanism step. So 4-member cyclic transition state is observed like this. Okay, that's why we are saying it is a syn addition. Okay, and it will be following anti-Marconi-Koff rule, like 4-member cyclic transition state is seen here. Okay, I hope it is clear. So each time this BH3 unit is there, na, each time see it will be reacting with 3 alkenes I told you, no. So each time that BH3 unit giving 1 hydrogen to the alkene. Okay, like that how many alkenes can be reacting? 3. So like you will get a species something like this. Trialkyl borane will get this upon treating with NaOH, treating with H2O2 in presence of NaOH gives you or alcohol as a final product, like OH group over here, hydrogen over here, that is it. Okay. Now tell me, which of the following statements is true about hydroboration reaction? So first of all tell me, it is a syn addition of water. Yes, syn addition of water only, no? We are adding H and OH to the alkenes. Yes, it is a syn addition of water. The next H3BO3 is formed as a byproduct. Yes, see we got this BOH now, BH3, right? BH3. So this treated with H2O2 NaOH mixture. So each time it is giving one hydrogen and that will be replaced by OH group. Okay, so BOH thrice will get, you can write this as H3BO3. Okay, yes, this is the byproduct. It is perfectly correct. It is a Markovnikov's rules addition. It is Markovnikov's rule, anti-Markovnikov's rule. Anti-Markovnikov. So this is incorrect. Okay, so now 3 moles of alcohols are formed as a product. Yes, so 3 moles of alkene gives react with 1 mole of BH, borane unit to gives 3 moles of alcohol. So this is also correct. So which is incorrect here? The only third option, C, option C is incorrect. Remaining are correct here. Okay, that's it. The next one, from preparation of alcohols from alkenes. Okay, using KMnO4. What is that? Using KMnO4. So what this KMnO4 will do here is, you just remember whenever there is a double bond. Okay, so treat this with a Bayer's reagent. What is this Bayer's reagent? Bayer's reagent is nothing but KMnO4 only, but dilute KMnO4 here. Okay, cold dilute KMnO4, or they will say Bayer's reagent. So all these things are same only here. The reaction will be same. KMnO4 in basic medium, dilute KMnO4 also they will mention. Okay, so now what happens is, just remove this double bond. Okay, after removing double bond, wherever the double bonds are there, that carbon should gain now OH groups. OH here and OH here, like this. This is the product. So what you can say, from KMnO4, like oxidation of alkenes or reaction of alkenes with KMnO4 in dilute or alkaline medium gives 1,2 diol, cis diols. Again you can remember 1,2 cis diol are formed. What are the products formed? 1,2 cis diols are formed as a products. When alkene, upon treating with dilute KMnO4 in basic medium, okay, or cold dilute also they will mention, cold dilute KMnO4 gives you cis diols. Okay, so now sir, why particularly you are mentioning it as a cold dilute means, if you take the same substance with a hot KMnO4, with what? Hot KMnO4, or they will simply mention KMnO4 with a delta symbol. Heat is nothing but hot only, no? So hot KMnO4 only, or they will mention hot KMnO4 in acidic medium, basic medium, like that they will mention. Okay, so if it is hot KMnO4, reaction will be more. Okay, so now what happens is, previously in cold condition only pi bond you have removed, and then you insert you inserted a OH group. Now when it is a hot KMnO4, both pi bond and sigma bond of this alkene carbon will get breaks. Okay, so it will breaks into 2 pieces like this. Okay, if it is breaking like these 2 pieces, now what is the species here? You have CH3 attached to a carbon, and that carbon contains one hydrogen here. Okay, and this is double bond carbon. So the double bond carbon is there now, so you there insert one oxygen. Okay, you are breaking now. Here only one bond you are breaking, there what you inserted? OH. But here you are breaking 2 bonds now, so to that put an oxygen. Okay, I am saying in a tricky way here. Okay, if there is any directly attached hydrogen, that will be converts into OH, carboxylic acid is formed. So then what about this side? Now tell me this side. This side you have CH2 unit, right? Now what happens to this unit? Tell me. See, this side double bond breaking now. So what to insert? This side. Okay, and this side hydrogens are there now. Hydrogen should be written as OH, like this. Okay, so since we are heating it, hot KMnO4, so here upon heating formic acid gives not formic acid, this is carbonic acid. Carbonic acid gives CO2 plus H2. These are the products. So acetic acid is formed, and this side it is giving you carbon dioxide and water. Okay, two hydrogens are converting into water and the carbon is converting into carbon dioxide. That's it. This is what you need to understand here. Okay, and the next one here is from osmium tetroxide with what? Osmium tetroxide. See, whatever you have studied above case like alkenes, upon treating with osmium tetroxide, the product formed is similar to that of above case. Like above case means cold KMnO4 we have seen now, same as cold KMnO4, remember, product formed. So what is the same as cold KMnO4 means? What is the product formed in cold KMnO4 case? What is the product formed in KMnO4 case? Cold KMnO4? 1,2 cis diol. Yes, here also 1,2 cis diol, like OH group here, OH group here. Cis diol, why you are specifying it as a cis? Because whatever the OH groups we are adding, that should be from the same plane, either from above the plane or from below the plane, like that. Okay, it's not a trans, it should be cis, like 1,2 cis diol should be formed, whether it can be osmium tetroxide or it can be cold dilute KMnO4. Okay, that's it. This is what you need to remember. Okay, the next one is here is so tell me this one. Yeah, this is from our discussion only. So propane 1-ol may be prepared by reaction of propene with, tell me which of this compound will give you propene. So what is this propene first? Propene means this one. So from here I want to prepare 1-ol, this one. So what is a suitable reagent? Like this means D, B, yeah, C. Like hydroboration gives anti-Marconi Markovnikov product, that is terminal carbon will take OH group. So this is perfectly correct. Now with the same question, instead of asking prop 1-ol, what if they ask propane 2-ol? Propane 2-ol. Propane 2-ol. So here propane 2-ol means what you need to get? You need to get a OH group over here. So how it happens, tell me. Yes, it is again easy. See, there is CH2 unit here now. Yeah. Now what happens? To this we are adding H plus. So where it will be goes? H plus will be goes to the terminal carbon, like this, by the help of these pi electrons, and this carbon will get a positive charge. Secondary carbocation is formed. So to this secondary carbocation we are adding H2O, water. So that water act as a nucleophile added over here. So that gives you OH group here, and this is CH3. Yes. So acidic hydrolysis of alkenes give you this kind of alcohols. So more stable or internal alcohol, I can say secondary alcohol comes from acidic hydrolysis of water. So 2-propanol can be prepared using option B. This 2-propanol can be prepared from option B, whereas 1-propanol can be prepared from option C. This is a hydroboration reaction. Okay, right. So the remaining things what we have. So yeah, before going to this, few more reactions are there. There is something called OM-DM reaction, oxymercuration and demercuration. This is short form I am writing it as OM-DM reaction. So here also alkenes with HgOAC, mercuric acetate, okay, mercuric acetate in presence of alcohol like water. What is this nucleophile here? Water is our nucleophile. Okay, this is first step, and second step we will be using NaBH4. Okay, yes. And here OM-DM reaction follows a Marconi-Markovnikov addition product. or product formed is similar to Marconi-Kafrul addition product. So remember few points. No rearrangement in the reaction, no rearrangement in the reaction, no rearrangement. Okay, wherever double bond is there, there we need to add. Okay, there is no rearrangement. And a three membered cyclic transition state is formed. What is that? Three-membered cyclic transition state is formed, and product formed is similar to Marconi-Kafrul addition product. Marconi-Kafrul product. Product formed is having what type of addition? Marconi-Kafrul addition. So what it will give is OM-DM reaction. The product formed is, if you are using water, the product formed is alcohol. If you are using water, what is the product formed? Alcohol. If you are using alcohol only as a nucleophile, product formed is ether. Okay, remember that. If you are using water as a nucleophile, alcohol will be the product. If you are using alcohol itself as a nucleophile, ether will be the product. Okay, that is the difference. Okay, so in OM-DM reaction, upon treating this with water, what will be the product formed? Alcohol. Okay, so what type of product formed here? Product formed is similar to Marconi-Kafrul addition. It means very simple. To this alkene, we are adding water. Okay, so what happens? Product formed is similar to Marconi-Kafrul means in water, what is the cationic part and anionic part? Negative and positive part. H plus is positive, OH minus negative. The negative part of addendum will be goes to least number of hydrogen containing carbon. Say anti-Marconi-Kafrul means more number of hydrogen containing carbon. Negative part goes to more number of hydrogen containing carbon. But here it goes to least number of hydrogen containing carbon. So which is containing least number of hydrogens out of these two carbons which is having a double bond here? There are two, here it is one. So which is having least number of hydrogens? This one is 2, this one is 1. This middle one is having only one hydrogen. There you need to add this OH group. So here you will get OH group here, and this carbon will be getting that hydrogen, CH2H, that's it. Okay, that's it. This is what you need to remember. There is no rearrangement. It's a three-membered cyclic transition state formed. Product formed is similar to anti-Marconi-Kafrul. Okay, and here what is the use of NaBH4? Yes, remember, see on the terminal carbon we are adding this hydrogen now. So this hydrogen comes from our NaBH4. Remember, this is important point. Okay, sir, why we are using NaBH4? See, when it is forming a cyclic transition state, that will be formed with the help of this mercury. So like this, a mercury three-membered cyclic ring is formed along with these two carbons. Okay, so this mercury we need to remove now. Okay, once after adding this water to the three-membered ring, ring opening takes place. So from that ring opened species, we need to remove this mercury. So we are using this NaBH4 to remove this mercury. So what is the use of this NaBH4? It is a demercurating agent. What is that? Demercurating agent. Okay, this is the importance of NaBH4. Okay, now one last question I am giving you here. So tell me, what will be the product upon treating this alkene with these things? OM-DM using water. Okay, or they simply mention this reaction instead of saying OM-DM, or if they say OM-DM also, you will get the same product as like this. HgOAc twice H2O followed by NaBH4. This is the first one, and second one is B2H6 H2O2 NaOH, and third one is H plus and water. So tell me, what are the products formed here in each case? Fast. I want your answer fastly. Yes, tell me. Like this one, what is the name of that reaction? Oxymercuration, demercuration. Tell me, what is the product formed? What I told you here, just consider this is an unsymmetrical alkene. Unsymmetrical alkene means what? Just check whether groups are same or not. Here not. So here one hydrogen, this is one methyl. So which carbon has hydrogen atoms? This one hydrogen is there is 0 hydrogens. So the negative part, oxymercuration, demercuration means we need to add water. Okay, so where this H and OH will goes, the negative part of addendum goes to least number of hydrogen containing carbon. So this is having 0 hydrogens, this contains 1. So which is having least number? The above one, 0 is least. There you need to add negative part. Negative part of water is what? OH. So here it will be OH, here it will be H. Okay. Now what about this reaction? Hydroboration reaction. Tell me. Tell me. This is also alcohol, but it follows anti-Markovnikov rule. Here it is Markovnikov rule. Tell me, what is the product formed? The negative part of the addendum goes to more number of hydrogen containing carbon. So where do we have more number of hydrogen? This one. This is 0. This is 1 means yes, this is more. So you need to add here OH, here H. So if you observe these two, product formed is different in both cases. Right now, this is OH is at the methyl group, here it is on the other carbon. Okay, now what about product in this case? So here it is CH3. Yeah, next. Where that OH will goes? First we need to add H plus to this double bond. If we are adding H plus, we should get a more stable carbocation. So if I add H plus over here, we will get a tertiary carbocation here. So then there you need to add this water. Okay, so your product will be like OH here, H here. So this is also follows Markovnikov rule addition product. Okay, if there is any chance for rearrangement, yes. In this last third example is here now. So in this case only rearrangement takes place, but not in the above two cases. Okay, rearrangement possible only in this type of reactions. It means I will give you one example, just take it and practice this. In the next class I will be explaining about this based on your response. Okay, yeah. So just tell me what type of product formed during the reaction of these compound H plus H2O. What is the product formed? What is the IUPAC name of this product? Okay, and this is a homework question. Please try, everyone who are watching this, both offline and online students. And here I am treating the same thing with Hg, OAC twice, H2O, NaBH4. What is the IUPAC name of this compound? Okay, and one more thing, BH3, H2O2, NaOH. What is the name of this compound? Like A, B, C. Whether these A, B, C products are same or different. What makes them different and what are their IUPAC names? Okay, so this is a question I am asking. Please try that and tell me your answer in the chat box. Okay, I hope this session is highly helpful. Those who are watching it live, if you like the content, please click on the follow button and also you can share with your friends. Okay, right. I am hoping that you will be sharing your answer for this question in the comment box. Okay, even if it is wrong, no issues. Please try to answer for this question. Okay, so thanks for watching. Stay connected with our NEET World channel. Thank you.